Hello, Elizabeth. My name is Scott Falstrom. I work with your parents at Miracosta College. So what I want to do is give you a brief little intro to a little bit with finance and kind of see how your student loans will possibly shape the way the rest of your life ends up. So what I'm going to do is just kind of show you where some resources are if you wanted to. If you're at the main Miracosta website, you can click on Menu, Math Learning Center, and down the side, Math Resources, and Math 95. And here, what you'll find is textbook and some keys, as well as some project and videos that kind of walk you through quite a bit with finance. I'll click on one of them. The first unit is all about finance, and it's pretty helpful. So you'll notice we have simple interest, compound interest, saving with annuities, and then amortized loans. So what I want to do is just kind of give you a brief picture on the small pieces and then kind of how the amortized loan piece comes together. So what I'm going to do first is talk a little bit about simple interest. Simple interest formula, the biggest one is that just interest is your principal, your rate times your time. The idea here is the amount of money that you're going to borrow or invest is a big part of how much interest you earn, but so is the rate and the amount of time that you keep the money or that you invest the money. So there's some examples here, but I thought you might want to kind of see what it looks like in real life. So if you were to invest with 5% interest and you put $100 in the bank, simple interest would allow you at the end of a year to earn $5 in interest, and your balance would be $105. But your investment doesn't change. So the next year, you would once again earn $5. So you can see your balance is going up every year. The amount of interest is not going up every year because simple interest is based on your investment, sometimes called your principal. Now, it's not the only kind of interest. The next type of interest we'll take a look at is called compound interest. So if we take the same interest, the same investment, notice here, $5, and I end up at $105 after a year. But while I've invested $100, my balance, if I earn interest on my balance, I'll earn a little bit more interest than I did the month before, bringing my balance now up a little bit higher. Notice the next month, even though I'd earned a quarter the first year, I earn a little bit more than a quarter the next year because I'm earning interest on the interest. Now this continues, and before long, I'm not earning $5 per year. Eventually, I'm earning $10 a year. And my balance has more than doubled. Eventually, I'm earning $17 per year, and I've got over 3 times my money. And this is called compound interest, where your interest is based on the remaining balance. This is the type of interest that you'll pay on student loans or on credit cards, houses, through a mortgage, or most car loans. You end up paying interest based on how much is left on the balance. You might decide, in order to kind of increase the amount of money in the account, to begin making maybe monthly payments. So take a look. In the first month, if we made a $50 payment, we didn't earn any interest because we just invested it. The next month, my $50 payment, this payment doesn't earn any interest, but I do earn a little bit of interest based on my remaining balance. What you'll start to see is that my interest goes up in a fairly predictable way, and before long I'm earning interest on the interest. So instead of 21 cents per month, I'm now earning $2 per month. I'm going to scroll down a little bit here, because after a while I'm earning $10 a month. Now notice I am still investing $50 every month into this account, so I'm putting a decent amount of money away. And I wanted to get down here to the bottom. After 10 years, which is 120 months, I'm earning $32 a month in interest, and I'm still putting the $50 away. If we kept this going, there would come a time right here where the amount of interest that I'm earning is more than the amount of money I'm putting into the account. So you can see the compounding interest really makes a big impact if you're the one earning the interest. Let's just take a credit card for example. And this is a type of loan. If you had a balance of $2,500 and you decided to make payments of $100, in this example, the interest is 14.99%, and we're compounding it monthly, which basically means each month they get a little piece of your annual interest. Well, take a look. I have interest that is accrued of $31.23 based on my remaining balance. So when I make a payment of $100, the whole $100 doesn't go to pay off the loan. The bank keeps $31.23 as their profit. They let the rest of it pay off the loan. The next month, there's a little less interest, again, because it's based on the remaining balance. As this continues, eventually you will pay it off. And in this example, paying $100 a month, you've paid $515 total dollars in interest. All right, so let's take a look at the book briefly, because as we get down to figuring out how loans work, loans require a formula that combines all of these pieces together. And so, this is the formula that puts all the pieces together. You have your principal, that's your loan amount. You have the interest you're accruing on your loan. There's the payment on the other side, and the payment is building up, and eventually the two sides will be equal. Two sides will be equal means you've paid your loan off. Come down here to a amortized loan for $375,000 over 30 years at 5% interest, and we could actually go through that. So I wanted to do that. I'll pull up a calculator. And so you can use a calculator that you have at home if you want. But notice $375,000, 30 years, and 5% annual interest. It is compounded monthly, which means I'll be making monthly payments. And the way I'd type it in is 375,000 times 1 plus, here comes my 5%, divided by 12, because I'm doing it monthly. Then I raise this to the 12 times 30. Here's the number you should see on the screen. Now really, this would be if you had 375,000. Go ahead and ask your parents. They'll just, give it to you in cash, and you invested it at 5% monthly interest. Over the course of 30 years, you'd have 1.6, almost $1.7 million. But that's not how the loan works. So I'm going to store this as A. If you need to, you can jot the number down. Make sure you put as many decimal places as possible. Now for the other side, I don't know the payment yet, so I'll actually have to do a little bit of work. I'll put in parentheses 1 plus 0.05 over 12. I'll raise it to the 12 times 30. And again, 12 means 12 times per year, and I do it for 30 years. I need a -1, and if you're interested where that comes from, I'd encourage you to read a little bit more in the book. It's kind of helpful. 0.05 divided by 12, and I'll hit equals. Now here's this 832. This is the factor that gets multiplied by your payment to get you to that total amount. So I'm going to store this as B. Now to find the final result, a little bit of algebra says I have A equals payment times B, and I want to get payment by itself, so I'll divide by B. In the calculator, I do alpha A divided by alpha B. And what this gives me is how much my payment has to be. And you'll see that number right here. The payment, rounding up here, even though you normally would round this down, if you round it up, you will have the amount paid off in exactly 30 years. So that's how we calculate this. So if you had a student loan, you would use this formula to find out how much your monthly payment would be. You could also use this to find out how much you paid over the life of the loan. So if we paid $2,013.09 and we made that payment 12 times a year for 30 years, here's how much money we paid. $724,000. If I subtract the amount I borrowed, which was the $375,000, you'll see I ended up paying interest of $350,000. So this gives you an idea of how you can use the math in the real world. Now here's the spreadsheet I made for you. What I did is I took a student loan where you type everything into the yellow boxes. It does all the work for you. You'll notice in the formulas, it takes care of all of the calculations that are needed. So for example, if it costs you $135,000 for your 4-year degree, and you're able to contribute $12,000, your scholarships are $5,000, what's left over, I'll bring this up here, $135,000 minus $12,000 minus $5,000 gives you $118,000 in debt. So those would be the amount you'd have to get loans for. And that's the amount that appears right here in the remaining balance. Now you don't have to do anything, it'll calculate all that for you. You should find the loan rate, if possible, for whatever loans you have. I looked up the current loan rate for federal student loans, and it's 4.45%. Most of the time, student loans have a repayment period of about 10 years. So I put in 10. To get you an idea of how much that's going to be, I'm going to zoom back just a little bit here. I also put in a formula that will calculate the payment for you. As a math teacher, I think you should probably do 1 or 2 of these on your own so you can see where that number comes from. But this payment is what comes right down here. And if you make that payment every month, the bank keeps their interest. Whatever's left over goes to pay off the principal amount, and your balance goes down. This will happen every month. I'm going to scroll down. And eventually, your final payment will terminate your student loan after 10 years. I put some numbers in here that I think will be helpful. Up on the side, you know your payment. And if you know your payment, it'll be paid off in 120 months. After 5 years, you still owe $65,000. And here's your total interest that you would pay on the loan itself. About $30,000. The reason I put this together for you is if you wanted, you could come back and change this payment. You could say, what would happen if I paid $1,500 every month? And it will automatically update, allowing you to see what happens if you paid a little extra. Remember, the extra doesn't change the interest, which is always calculated on remaining balance, but it does increase the amount going to principal, which will reduce the remaining balance of the subsequent months. And as you scroll down, if you need to, you can, but it's right up here in the summary chart. You'll have this one paid off in 94 months, and it'll save you about $7,000 in interest. If you'd like to go back to the original, press the equal button and click on that total payment. press enter, and it will recalculate for you. Now, so that you can see it visually, I've also put in a graph. This graph illustrates every payment you make on your student loan, and the amount of money that goes to interest is down here in blue, and the amount of money that goes to principal is up here in red. So you can start to see the compounding effect. As you pay more and more on your student loan, the amount that goes to interest goes down over time. All right, last piece. Let's just say that you're having trouble making your payments. Most of the time, student loan debt is not forgiven in bankruptcy, but the student loan companies will work with you. There's two ways that they do that. One, they extend your period of time to repayment. I'm going to go zoom in a little bit more here. Let's now say they say to you, okay, Elizabeth, I see you're having trouble making your payments. Why don't we just give you 20 years to pay it off? Now, before I hit enter, keep track over here at the interest paid. No problem, they say. It's no problem to them. Instead of having $28,000 in interest, now they have $60,000 in interest. Notice your payment decreased because you're making payments for much longer. Typically, if they have to adjust the length of time, they'll also adjust your interest rate. Instead of 4.45, you might get an interest rate of, say, 6.25. As you can see from the total interest, you're now at about $90,000 in interest. Your payment is $862.50, and you would make that payment for 20 years. If you zoom back and take a look, you can begin to see, wow, much more of my payment is going to the bank than the principal is going to pay it off. And you can also see that here with the actual numbers. So I'm going to return this back to the original state because I want you to see it. And you can kind of mess around with it as well. You could also kind of take a look and see what would happen if I had more scholarship money over the course of the 4 years. Maybe you have $15,000 in scholarships. Again, the second you hit enter on one of those numbers, you can see what your new payment is. If you were able to contribute more out of pocket, either you or your family, this number might go up. Perhaps they could afford $6,000 a year, which would be $24,000. Again, the balance is automatically updated, as is your payment. Just for fun, for you or your parents, I also put in a tab down here for mortgage loans. If you end up looking for a house, you can take a look at the price of your home, how much your down payment will be, roughly additional closing costs, what rate you can get, and how long you want to pay it off. And then taxes and insurance if you really want to get into kind of the details of the home. Payments calculated for you, the closing costs are calculated for you, and the total payment is as well. Anything in green is automatic, anything in yellow, you're the one in charge of. So if I put a little yellow here, you'll know you're in charge of this ultimately. I think it's kind of a good idea to see a little bit as well. If you bought a home for $785,000, paid 20% down, this is how much you still owe on the home. You still have 80% of that amount to pay off, and you can calculate how much interest you pay. It hurts. But remember the joys of investing. Making payments into a bank where you're earning interest can start to benefit you. It's when you have to pay the interest that it really starts to be better understood how money really works. So I hope you learned a little bit, and I look forward to any questions you might have. All right. Have a great day. Bye-bye.